Yeah, we're going. All right. So yesterday we talked about operations. Our operations were adding, subtracting, multiplying, and dividing of functions. We handled that fairly well. A couple of glitches there. Domains of functions, we can handle that. Okay. 2 rules: look for fractions, look for radicals. Okay. Domains on operations of functions. So that was where we got to think a little bit more because there's more things that are going on. Today I want to nail composition of functions and then domains of compositions of functions. So that's where we're going to hit up today. So we're going to jump ahead to this one. Okay? So you decided that your jalopy that you need to take to go to work and school and play and all that fun stuff needs to be replaced. So you found a car, okay? $15,000 car.
Well, brand new car.
Okay? All right? Now, auto dealerships will often run programs and stuff to try and get you to come in and buy a new car or buy a used car or whatever. Okay? So the dealership is running 2 programs, incentive programs to get you to come in and buy the car. The first one is they're giving you a rebate of $2,000. The second one is that they're giving you a 5% discount off of the purchase price of your vehicle. Okay? Luckily for you, you caught them on a good day where they're going to apply both of their incentive programs for you. Okay? You now need to be a smart consumer and figure out how you want them to apply it. Okay? I'll give you 5 minutes. Alright, so if I apply the rebate first, that means it's going to be $15,000 to buy the car. I'm going to subtract off $2,000 right off the start. So now I'm only paying $13,000. Yes? Okay. Then they want to apply the discount. Now, side note, if I'm getting a 5% discount, that means that I am paying $95% of the total cost. Okay? Then that way I don't have to do anything with subtraction. Okay? So 95% is in decimal form 0.95 times 13,000 gets me a total cost that I have to pay, granted this is before tax, title, and license, of $12,350. If I apply the discount first, then that means that I would be paying 95% of $15,000. So that's going to be $14,250. Then apply the rebate from that. Oops, tap the brakes. Let's put that into that color. And then now we're going to apply the rebate, which was in red. 14,250 minus 2,000 tells me then that my final bill here, again, before tax, title, and license, was $12,250. Okay? So for me, it seems to be more advantageous to do it the second way as opposed to the first way. Okay? What we've done there, what this was an example of, was not only real-world math, but this was an example of a composition of functions. A composition of functions is where you take one function and you evaluate it under certain conditions. Then you take that value that you got out of that first function and you plug that value into a second function. Okay? If we were dealing with these two as functions, the rebate function would be x minus 2,000. Okay? The discount, or the discount function would be 0.95x. Okay? So we took the value of one, plugged it into the other one, and then vice versa it. Okay? Now, does it make sense that they don't give me the same answer in the end? Does that make sense to you? Okay? Because they're two totally different functions. Okay? It would look funny if you put your pants on first and then put your underwear on. Okay? Okay, that's a different function than doing it the normal way, which is putting your underwear on first and then putting your pants on. Okay? Now, sometimes you might get the same answer in the end. Okay? You might end up getting the same answer. If my first function was I put my shirt on, and my second function was I put my pants on, I'm going to end up at the same outcome no matter which one I apply first. Okay? But if it's I put my shirt on and I put my jacket on, or pants and underwear, whatever you want to go with, okay, you might not get the same answer. But it is possible to get the same outcome by going vice versa. Okay? So, I'll give you a couple of seconds just to get back into the hint of evaluating functions under certain conditions. So please try those two. Evaluate k, function k at 8, and evaluate function d at 0.5. So if I'm looking at k of 8, then that's going to be 3 times 8, then plus 2. 3 times 8 is 24, plus 2 is 26. So the value of my function k at x equals 8, or otherwise known as k of 8, is 26. D of 0.5 means I'm going to put 0.5 into function d where x is. 4 times 0.5 is 2. 2 minus 7 is negative 5. So d of 0.5 is negative 5. Should be no surprises there. Okay? Composite form, now this is what it looks like. Okay? This is saying we want to find k of d of 3. So you start on the inside here, and you first find d of 3. So I evaluate function d at 3. That's going to give me 4 times 3 minus 7. 4 times 3 is 12, minus 7 is 5. So d of 3 is 5. Now I take that value of 5 and I put it into k. So I need to evaluate k at 5. So then this becomes 3 times 5, then plus 2. 3 times 5 is 15, plus 2 is 17. So k of d of 3 is equal to 17. Questions on how I did that? This 4 right here, that's from my function d. give you a minute to figure out what d of k of 3 is. The answer is 17, right? Should be? Should it be 17? No. Okay, because you're going in a different order, right? So k of 3 is what we need to find first. No, I'm talking about this one. Yeah. Yeah. K of 3 becomes 3 times
3 times 3.
3, then plus 2. So that's going to be 11. Then I need to figure out what d of 11 is. So that's going to be 4 times 11, then minus 7. 4 times 11 is 44, minus 7 is 37. So d of k of 3 is 37. Again, you're applying two different functions in different orders. Yes, in the end, you could get the same thing, but most times, 9 times out of 10, you're probably not going to get the exact same thing. Okay? Sorry, my OCD is kicking in. It's a real thing, Joey.
Why don't you move on to the next slide?
Why don't you stop yelling at me? Okay. So, utilizing what you just learned, find me g of h of 7 and h of negative 3.
Yeah, they're not impressed.
So there's no parentheses. So you should think about it at the end. Watch.
It's okay.
Not saying you're not going to get any fights like the team that you play with my later.
No, I just wanted to ask you.
So I got g of h of 7 is negative 1. Yes, sir.
Why didn't you just put the negative so the 1 is then?
Because h of 7 is 1, right?
Yeah.
Okay. And in g of x, this, let me go in purple, this is not being controlled by the square. Only the x is being controlled by the square. If it was like this, then the negative is now being controlled by the square. But it's not like that, so it's just the 1 is being squared. And then being multiplied by negative 1. H of negative 3 is going to be negative 3 minus 2 divided by 5. That's going to be negative 5 over 5. That's negative 1. So then I need to find h of negative 1, which is negative 1 minus 2 divided by 5. So that's negative 3/5. So h of negative 3 is negative 3/5. What's the tweak that I made on this slide? It's x. There's no numbers. So when it's this, what you're finding is you are finding the composite function. You're not evaluating it. So far up to this point, you've been evaluating. Now you're finding the actual function that would be k of d of x. Okay? exactly the same way. So first I need to substitute x in for x into d, which just becomes 4x minus 7. If I replace x with x, I get 4x minus 7 out of 4x minus 7. Okay? Then I need to find k of 4x minus 7. Well, here this now becomes 3 times 4x minus 7, then plus 2. So I replace x with 4x minus 7. Doing some fancy math, this becomes 12x minus 21 plus 2. So the function k of d of x is 12x minus 19. Now, we earlier found that k of d of 3 was 17. Right? We found it right there. K of d of 3 is 17. Okay? Now, if I put 3 into my function here, so then if I put 3 here in, we'll go purple, 12 times 3 minus 19 is 36 minus 19, which is 17. Okay? So we could utilize that function and we can graph that function, or we can evaluate that function if we had multiple ones to do. Like if I gave you 20 of these to do, k of d of something, I would first find this function, and then you're only plugging it into one function instead of dropping it into 2 or 3. Okay? Utilizing that knowledge now, you find me d of k of x. K of x is 3x plus 2. So then I need to find d of 3x plus 2. Well, that's going to be 4 times the quantity, 3x plus 2, then minus 7. That's going to be 12x plus 8 minus 7, which gives me d of k of x is 12x plus 1. Earlier we found d of k of 3, and we got that to be 37, right? Well, 12 times 3 is 36, plus 1 is 37. Okay? Domains of compositions. Okay? Consider f of g of 2. Okay? Just any old functions, f of g of 2. If evaluating g of 2 doesn't work because x equals 2 is not in the domain of g, okay, that would be an issue. Or if g of 2 equals some value that wouldn't be in the domain of f, that's another problem. Okay? Okay? So we've got to watch what goes in where and what's going into what, and who's going in doing this and who's doing that, and that's why I have a shirt at home that says math is hard. Okay?
Yeah, you sure? Okay. No, that's not Thursday.
Can't,
Why not?
Friday.
because it's old.
It's a Tuesday.
No, it's from Fatlands.
Oh.
Yeah.
Still hurt.
Okay. So f of x equals 3 over x plus 1. G of x equals 2x minus 5. Find g of f of x and state its domain. Okay? So let's find, first let's do g of f of x. So f of x is equal to 3 over x plus 1, right? Okay? So g of 3 over x plus 1 is going to be 2 times 3 over x plus 1 minus 5. So this becomes 6 over x plus 1 minus 5. So that would be like 6 over x plus 1 minus 5 times x plus 1 over x plus 1.
Wait, why do you only distribute the 2 to the top of the fraction?
Because the parentheses stop. Or why just to the top?
Wow.
Because when I multiply fractions, I multiply straight across, right?
Oh. Sorry if I was dumb.
Nope, that was a good question. Okay. So then this becomes 6 minus 5x minus 5 all over x plus 1. So g of f of x is equal to negative 5x plus 1 over x plus 1.
What happened to the 6?
6 minus 5 is 1. Okay. So let me rewrite that up here so we can see everything now. So that was g of f of x is negative 5x plus 1 over x plus 1. So now you've got to ask yourself some questions. First question, what is the domain of f? Of f?
All real numbers and
Of f. X can equal negative 1. So it's all real numbers except x cannot equal negative 1. Then you got to ask yourself the domain of g.
That's all real numbers.
All real numbers. Then you got to ask yourself, what's the domain of the composition?
All real numbers except x can equal negative 1.
Except x can't equal negative 1. Okay? Now, you were taking f and you were putting it into g, correct? Okay? So are there any extra values of f that you could come up with that would make g not work? 2.5? Nope, because I can get g being 0. What's the two things that I look for when I'm looking for restrictions? Two things that I'm looking for from yesterday. I look for fractions. And what am I looking for in that fraction? What about the denominator?
There's a variable.
If there's a variable in the denominator. Okay, what's the second thing I'm looking for? Radicals. Okay? First off, are there any radicals in this problem? No, so I'm not worried about radicals at all. Okay? Now I'm taking f here. I'm taking f and I'm putting f into g. Right? So So are there any possible restrictions on G? Are there any restrictions on G? No, there's not. So I don't have to worry about any extracurricular type stuff. Okay? So then I'm just looking at those three. So my domain here then, the domain of G of f of x, it's going to be all real numbers, right? But f can't give me -1. So that's going to get kicked out. G I don't care about because that domain is all real numbers, so there's no extra ones there. And based off just solely off of my composition, we already have the fact that there is that one in there. So here is the function. Here is the domain. Yes, sir.
What happened to the 6? I found G of f of x. What happened to the 6?
Right here,
Yeah.
I combined it with this.
Yeah, but
We
then
went over that already.
You combine like the
6 minus 5 is 1. Okay, try that one. Okay.
I am completely lost. Of course you are.
So v of x is 3x, right? What's the domain of v of x?
All real. All reals.
Okay. Then I need to find w of 3x.
Which equals radical.
So w of v of x is equal to the square root of 6x
You got there.
plus 1. Okay? Then, now I need to find the domain of w. So if I'm looking back just at w, then I have to say to myself, well, 2x plus 1 has to be greater than or equal to 0, which means that 2x has to be greater than or equal to -1, which means x has to be greater than or equal to -1/2. Everybody agree with that?
Yes.
Okay? So the domain here then of w is all reals, but x has to be greater than or equal to -1/2. Now, I've got to look at the composition. So I need to figure out, I've got to look at 6x plus 1 has to be greater than or equal to 0. So 6x has to be greater than or equal to -1. So x has to be greater than or equal to -1/6. So the domain of my composition
All reals.
is all real numbers with the exception of x is greater than or equal to -1/6. Because now I need to give the domain of my final composition. So the domain of w of v of x is going to be all real numbers, but something, right? So now we got to take a peek because these two right here are different,
Yeah.
right? So we got to figure out one of them is going to be a little more controlling than the other. So if I'm looking at a number line, -1/2 is there, -1/6 is there, right? Basically what I'm looking at is I'm looking at this these middle numbers. Okay? So if I take a middle number, let's say 1/3. Negative 1/3 is in between negative 1/6 and negative 1/2. And I plug that number back into my function, my composition, my composite function. That's the one I'm plugging it back into. I get 6 times negative 1/3 plus 1, which is negative 2 plus 1, which is negative 1, right? And all of that is being square rooted. Do I like, in real numbers, do I like the square root of negative 1? No, because it's imaginary. So all of this in here doesn't work for my composite function. So then I just take the end one, x is greater than or equal to negative 1/6. Work for tonight is the same as last night, okay? Still due on Thursday. No formative